How to avoid mutable parameter side effects in Python. Imagine you are cooking and you add salt to a dish. If you accidentally add too much, it can ruin the flavor. In programming, passing mutable objects like lists or dictionaries to functions can cause similar surprises if they are changed unintentionally. Today, we will look at how to keep your data safe from unexpected changes when working with functions in Python. In Python, some objects like lists and dictionaries are mutable, which means their contents can be changed after creation. When you pass these objects to a function, the function gets a reference to the original object. If the function modifies it, those changes will be visible outside the function too. This is called a side effect. Side effects can make your code tricky to follow because changes in one part can unexpectedly affect other parts. Python handles function parameters by passing references to objects, not copies. So if you pass a list to a function and the function adds or removes items, the original list will also change. This can be useful sometimes, but often it leads to bugs if you didn't mean to change the original data. A common mistake is using mutable default arguments in function definitions. For example, if you write a function with a list as a default parameter, that list is created once when the function is defined. Every time you call the function without providing that argument, it uses the same list. If the function modifies the list, those changes stay for the next call, which is usually not what you want. To prevent this, a good practice is to use immutable types like strings or tuples for parameters whenever possible. These cannot be changed after creation, so they won't cause side effects. But if you need to work with a mutable object inside a function, create a copy of it at the start. For lists, you can do this with slicing, like newList equals oldList colon, or use the copy module for more complex objects. Another effective method is to set the default value of a parameter to none. Inside the function, check if the argument is none, and if so, create a new object like an empty list. For example, define the function with data is equal to none, then inside, if data is none, assign data to an empty list. This way, each call gets a fresh list, avoiding shared state. It's also helpful to be clear about side effects. If your function needs to change data, name it accordingly or document it well. This way, other programmers know what to expect and can avoid unintended bugs. Remember, functions that do not change their inputs are easier to test and reuse. They behave predictably because their output depends only on their inputs. This makes your code more reliable and easier to understand. To sum up, always think about whether your function modifies its inputs. Use immutable types when possible, make copies of mutable objects before changing them, and avoid mutable default arguments. These simple steps will help you write cleaner, safer Python code that behaves exactly as you intend.